Welcome back to Defense Tech World. Today, we're diving into one of the most advanced creations of modern warfare, the P-270 Moskit missile. These high-precision machines are not just weapons, they are masterpieces of technology, engineering, and strategy combined into a single, powerful system. Behind every missile lies decades of innovation, thousands of components, and the combined effort of scientists, engineers, and defense experts. So, let's explore what makes the missile, especially the legendary P-270 Moskit, one of the most fascinating creations in the history of military technology. Lightbulb. What is a missile? A missile is far more than a simple rocket. It's an intelligent weapon, a guided projectile capable of detecting, tracking, and striking a target with remarkable precision. Every missile, no matter its purpose, shares three main parts. 1. The propulsion system. 2. The guidance and control system, and 3. The warhead. Each component plays a vital role in ensuring that the missile not only reaches its target but does so accurately, efficiently, and reliably, even in the harshest conditions. Gear. The propulsion system, the heart of motion. The propulsion system is what gives a missile its power, its heartbeat. Some missiles use solid fuel rockets, which provide instant thrust and are ideal for quick response launches. Others rely on liquid fuel or turbojet engines for longer range, more sustained missions. Then there's the ramjet, an advanced engine that compresses incoming air at high speeds to burn fuel more efficiently. It has no moving parts, yet it can propel missiles to incredible velocities, a hallmark of the P-270 Moskit. Rocket. The Moskit's engineering genius. The P-270 Moskit, known by its NATO codename SS-N-22 Sunburn, was developed by the Soviet Union's Raduga Design Bureau in the 1970s. It was specifically designed to destroy large naval targets, primarily aircraft carriers and destroyers. Its propulsion system combines a solid fuel booster for initial launch and a liquid fuel ramjet engine for sustained flight. Once airborne, the missile accelerates to Mach 2.5, about 3,000 km per hour. At that speed, the Moskit can travel its maximum range of 120 km in under 2 minutes. Its sheer speed and low-altitude flight path make it almost impossible to intercept. Compass. Guidance and control, the missile's brain. Speed means nothing without control. The Moskit's guidance system is a work of precision engineering. It uses inertial navigation to stay on course during the early phase of flight, then switches to active radar homing as it closes in on its target. This radar system allows the missile to detect, identify, and lock onto an enemy ship completely autonomously. Even if the target changes course or tries to jam the signal, the Moskit can make real-time adjustments to stay locked on. To make it even deadlier, the missile flies in a sea-skimming trajectory, gliding just 10 to 20 meters above the water. At that altitude, radar systems have almost no time to react before impact. The missile's control fins and onboard computer constantly correct its flight path to maintain balance and stability, even while traveling at supersonic speeds through turbulent sea air. Collision. The warhead, the final impact. Now comes the payload, the part that delivers the strike. The Moskit carries a 300-kilogram high-explosive warhead, designed to pierce through reinforced ship hulls before detonating inside. The blast and secondary fires can cripple even the largest naval vessels. Some variants are capable of carrying nuclear warheads, though such configurations are rare and strictly controlled. Different missiles use different payloads depending on their missions. Fragmentation warheads for anti-air defense. Penetrating warheads for bunkers or armored ships. Kinetic impactors that rely purely on speed, and non-lethal payloads for training or electronic warfare. Each design balances destructive power, weight, and control, ensuring the missile performs exactly as intended. Ice cube storage, handling, and safety. A missile is as dangerous to its own operators as it is to its enemies if not handled correctly. For that reason, missiles are stored under strict safety and environmental controls. The P-270 P-270 MOS kit is typically housed in sealed cylindrical canisters, mounted on ship decks, coastal batteries, or mobile launchers. These canisters protect the missile from humidity, salt, and temperature fluctuations, allowing it to remain combat-ready for years. Strategic missiles, such as intercontinental ballistic types, are kept in reinforced underground silos, where temperature and pressure are carefully maintained. Every missile is fitted with electronic safety locks, fuse protections, and monitoring sensors. Teams of engineers and technicians inspect them regularly, ensuring fuel stability, seal integrity, and electronic readiness. In short, storage and safety are as critical as the missile's design itself. Water wave role and tactics of the P-270 MOS kit. The MOS kit wasn't designed for general warfare, it was built for naval dominance. During the Cold War, Soviet strategists needed a missile that could penetrate the powerful defensive screens of U.S. carrier groups. The MOS kit became their answer. Its launch sequence is breathtaking. From the deck of a ship or coastal launcher, the booster ignites, lifting the missile at a sharp angle. Within seconds, the ramjet takes over, and the missile levels off, racing toward the horizon just meters above the sea. The future of missile technology. We're now entering the hypersonic age, where missiles can exceed Mach 5 times the speed of sound, while maintaining maneuverability. These new systems, often called hypersonic glide vehicles, don't follow predictable ballistic paths. Instead, they glide through the upper atmosphere, changing direction unpredictably. This makes them nearly impossible to intercept with traditional defense systems. But the future of missile development isn't only about speed. Engineers are working on AI-driven guidance systems, networked swarming tactics, stealth coatings to reduce radar signatures, reusable launch bodies, and eco-friendly fuels that reduce maintenance hazards. Missiles of the next generation may be able to make split-second decisions, reroute in real time, or abort missions autonomously if conditions aren't ideal. It's a blend of artificial intelligence, advanced materials, and extreme physics, where science fiction is quickly becoming science fact. Balance scale responsibility and control. Yet, for all their brilliance, missiles also remind us of humanity's greatest responsibility: control. Every new advance in weaponry brings both protection and danger. These systems can defend nations, but in the wrong hands, they can cause irreversible devastation. That's why international treaties like the Missile Technology Control Regime, MTCR, and New START exist, to prevent uncontrolled proliferation and encourage transparency. Modern defense industries also focus on precision rather than mass destruction. The goal is to neutralize threats efficiently, minimizing civilian harm and collateral damage. The line between deterrence and destruction has never been thinner, and managing that line defines the future of defense. Satellite missiles as symbols of human ingenuity. When we look at the P-270 MOS kit, we're not just looking at a weapon. We're looking at the result of thousands of hours of design, mathematics, material science, and human imagination. It represents a paradox, the best of human engineering built for the worst of human conflicts. From the Tomahawk to the BrahMos, from early subsonic cruise missiles to the cutting-edge hypersonic gliders of today, every generation of missile pushes the boundaries of what technology can achieve. Film frames conclusion. So the next time you see a missile launch streaking across the sky or slicing over the ocean, remember, you're witnessing the pinnacle of physics, computing, and design, a flying ecosystem of sensors, engines, and control systems working in perfect harmony. The P-270 MOS kit stands as a monument to that achievement, a symbol of how speed, precision, and intelligence can be fused into one unstoppable force. Thanks for watching Defense Tech World. If you enjoyed this deep dive into the P-270 MOS kit and the science of modern missile systems, don't forget to like, share, and subscribe.